Okay. So in yesterday's session, we have discussed data warehousing concepts, the fundamentals, why we build data warehousing applications, and what are the ETL concepts. Okay. And the architecture of data warehousing, characteristic features of data warehousing. Okay. And different ETL tools in the market, and the data acquisition process, like extraction, transformation, and loading. What are the different extraction types, like internal sources, external sources, and different types of data loading phases. Okay, so that we have discussed data merging. I mean, like transformations, like merging, cleansing, okay, and scrubbing and aggregation. Okay, so these fundamentals are very important. Okay, so you should know this because you are working in data engineering stream, in data analytics. Okay, so next. Now, today's session we will discuss what is the data mod, types of data mods, and dimension modeling. Okay, so data modeling, what is data modeling? What are the types of schemas? Okay, so whenever you are building a data warehousing application, you need to have some architecture schema. So to have the data availability and the relationships among the entities, different entities. So when you are building data warehousing application, so you'll be having different types of data load. Okay. So here, what is the schema that suits you to build the application? So those things we will discuss in today's session. Okay. And what are the different types of dimension tables? So normally from the staging area to we'll be loading the data. Main data must tables, that is dimension tables, it deals with a specific subject. Suppose for example, customer dimension deals with the customer data, and will be maintaining current and as well as historical data, and also will be maintaining the active records in the fact tables, okay? And different types of fact tables, and what is the surrogate key, how to implement slowly changing dimensions, what is the primary key, what is the foreign key. So those things we will cover in today's session. Okay. So what's the data mod? So what's the data mod? What's the data mod? So data mod is nothing but it deals with a specific subject. Okay. So data mod is nothing but it deals with a specific subject. For example, I have a data that deals with the customer. Okay. So here I have data that deals with the customers. Okay. So here in this data mod, I mean, like it has information related to a customer. For example, it's a product. Let's take an example of a product. So product, it has the information related to all the what are the products that we are manufacturing. Okay, so the companies manufacture the product ID, product name, product description details, and the product manufacturing date, expiry date, and the barcode number. All these details are available in product dimension. And look at region. Okay, so region, what are the various regions that we are operating the business? So like that, it deals with a specific subject. Okay, so here we'll be dealing the data with a specific subject. Okay, so that will be calling it as data mart. So data mart is a subset of enterprise data warehouse. It's like a part of sub-unit at a data warehouse. So data warehouse, we have all the different subject areas data. Here we have different subject areas data. Okay, so it deals with a specific subject here, and this data marts helps us to take a business decision at the middle level management, like department heads. Okay, so they are the uh, head, and they used to take care of the entire business. Okay, so they used to report to the top level manager. For example, sales and marketing head. So he's responsible for entire sales and sales. What is sales or promotional activities in the organization? Okay, so these data marts are built to support business decision at the middle level manager. So here we have two types of approaches for building the data mart. So what are those two approaches? So dependent data mart and independent data mart. So what is dependent data mart? What is independent data mart? Now let's discuss. So normally whenever you are building a data warehousing application, the criteria here will be focusing on like there should be a proper approach how the data that we are going to receive and what is the strategy that we are going to build the data warehousing application. Okay. So for example, I want to build enterprise data warehouse first. Okay. So this is the first approach, like building the data warehouse first. Then let's focusing on building the data marts later. Okay. So according to WRH Human, he's saying that let's focus on building the enterprise data warehouse first. All the data, different entities, different subject areas. You can load all the data at one time by following the methodology called enterprise data warehouse, by building the enterprise data warehouse first. Okay, so this is one of the approach. Okay, so once we load, when we build this enterprise data warehouse first, then we will be focusing on separating the data with respect to subject-oriented data. So this is one method where we are building the data warehousing approach, that is top-down approach. Top-down. From the top, we are building the top the enterprise data warehouse. After that, we are separating the data with the respect to data modes. Okay, so this is one method. Okay, another method is here. Ralph Kimball is saying that let's focus on building the bottom-up approach. So it's very easy to build data marts rather than enterprise data warehouse. For example, if you want to build the top-down approach, like if you want to build enterprise data warehouse, you have to connect. You need to have a big table. Okay, so the table you need to have the complexity of joins and different various data stages. Okay, so that will helps us. It will take a lot of time. Okay. And here the complexity joins multiple tables, and we have to bring all the attributes related to various subject areas into one table. So that is the primary focus of building this top-down approach. But when compared to bottom-up approach, here it's very simple to build the data mart. It deals with a specific subject. For example, customer data. So customer data here will be receiving data in a form of file. For let's take an example. From customer file, we'll load the data into staging area and we'll compare the CDC. We'll update the data and load it into actual data mart table. So this is very easy in building the data mart. So after that, we'll be loading all the data marts data into enterprise data warehousing layer. Okay. So bottom up approach is very easy because we are not depending on the data for an enterprise data warehouse. So this is an independent data. Okay, so bottom up approach is a independent data mart. Whereas dependent data mart is like if you want to build a data mart here, we need to depend on enterprise data warehouse. Okay, so majority of the organization they will be focusing on building this individual independent data marts first. Okay, independent data marts. Okay, so then it is very easy to build enterprise data warehouse. Okay, and the next one is data warehousing life cycle. So any questions here before I move to the next topic? Any questions? You can type in the chat box. So meantime, let's open DataStage VM. So any questions, guys? Not receiving any response. Okay, great.
No, sir.
Okay. Right. So now let's discuss about business requirement analysis. Okay. So what is meant by business requirement analysis? For example, whenever you are building any project, so any application you want to build. Okay. So here we need to have a clear understanding about your application. We need to gather all the requirements. So normally business analyst will be there. So they used to coordinate with respect to end users. Okay, so product owners. Okay, so all are involved, and the architecture team they will be involving and gathering all the requirements. Okay, so once the business requirement analysis document is ready, then the architecture team is mainly focusing on building the data models. Okay, so what are the database that we are going to use to build a database? I mean, will be selecting one target layer to store the data in the DB. And also here, we will be considering what are the sources, how you are going to receive the data from the source. Okay, so that information. Okay, so those details and all, we need to gather all the information. Like so, I mean, like we are installing DataStage normally in the Unix, IBM Ajax Unix. Okay, so there we need to mention the path. Okay, so source files details, rejected file details, socket files. Okay, so inbound and outbound processing. That all these things will need to consider. Okay, and what are the logics? I mean, like the mapping logic. So, what is the source? If it is a file, what we are going to do with the file? Where we need to load the data? So, those kind of information will be clearly defined in this data modeling. Okay, so here we'll be defining the mapping sheets. Okay, so once this design and mapping sheets are ready, then the next step is ETL development lifecycle. Okay, so ETL development lifecycle here, what happens is parallelly, the similarly reporting team also start developing the reports after once the ETL team started developing the jobs, once the data is ready. Okay, so they will be having this loaded some sample test data. So meantime, the reporting team also prepare the reports like Tableau, Power BI. So here, for example, the ETL team will develop the jobs. Okay, so by using the ETL to DataStage, and once the development is completed, we will move the code to QA environment. Okay, so we'll move the code to QA environment. In the QA environment, what happens? The QA team will come into the picture and they will start running the jobs. And once they will start testing the data set. So they will check the source data, they will check the target data, whether the data is loaded correctly or not in the target, any data policies violations. Okay, so any duplicates that you are going to receive. Okay, so for example, data is there in the source, but it's not pulling back into the target. If these kind of scenarios, normally they will test with all these test cases. So for each process, the testing team is responsible to build the test cases, and they will test in a given environment. Once everything is fine, then they will move to the code to evaluate user acceptance testing pre-prod. Okay, so if they find any issue, so what is the next step? Okay, so that who is the job? I mean, like particular process who develop the DataStage jobs. So they will assign the ticket to developer. Okay, so normally for ticketing tracking tool, we'll use Jira or HPQC ALM. Okay. So they will be raising a bug, and they have to. A development team have to look into the issue in case of any issue in the data side. Okay, so normally testing team they will test only with the data only. Okay, and also uh, they will check the code format standards and all whether you make it properly or not. So that also they will check. Okay, so here what happens is like the developer again retest check the issue and they will modify the code. I mean, to get the required output. Okay, so that is the responsibility of a DataStage developer. So then once everything is fine, everything is fine, then again they will ask the tester to retest it again. They will migrate the code to give environment. Okay, so if still the testing team is still facing, I mean, like any concern that rise, again the development team has to take a look. Okay. So this will be keep on rotating until you developer fix the issue. Okay, if everything is fine, then there move the code to UAT. So UAT will be having the partial live data where the business team and product owners come into the picture and test all the reports and all. Okay, all the data. And all. So here we can see like similarly we'll be having the reporting life cycle also. So here once we load the data in the warehouse, from the data warehouse, data mart tables, they will fetch the data for developing the reports. So here normally Tableau, Power BI, Cosmos, Business Hub, these are the reporting tools. Okay. So here the reporting team will develop the reports and there will be dedicated testing team for the reports as well. So this also works the same way. And whether we are expecting the correct data in the report or not. So those kind of testing that the reporting team will do. Okay. So once we got the UAT sign off from the business team, then we are going to deploy the code into production. Okay. So for if the jobs are running on daily basis, for example, jobs are running, I need to update the data. I need to update the data. I need to update the data on daily basis. Okay. So then we need to support 7 days, 5 days. I mean 5 days. Okay. So 5 days we have to support as a hypercare. Hypercare. 5 days development team responsibility for in case of any failure in the production once we deploy in the code. So on 4th day or they will capture all the issues. Okay, capture all the issues. Okay, on the 4th day. So they will identify all the issues. Okay, so and they will redeploy on the 5th day itself. 5th day on the 4th day itself. Okay, so 4th day they will capture all the issues and they will prepare again, redeploy the group. They will make necessary changes and they will retest once in pre-production. And if everything is fine, then they will deploy the code in the production. Okay, so if everything is fine, then the support team will come into the picture. Support team. Okay, so supporting. So they are responsible for ongoing monitoring and support activities. Okay, if it is monthly, 1 month monthly load. Okay, so jobs data will be refreshed monthly once. Normally procurement process, they will refresh the data monthly twice. For example, starting of first 5 or 6 business days, so up to 10th, they will settle the payments to the vendors. And that data we have to update. After 28th, they will update the systems again. So procurement process will run monthly twice. So if it is running monthly twice, then first month will be supporting, development team will be supporting it for the first month. And second month onwards, the support team has to be taken care. So this is the flow that we are going to follow in the building the data warehousing application, the life cycle of data warehousing. So any questions here? So any questions?
I'm good, sir.
Okay. What about others? No questions. Okay. Right. Right. So now let's move on to the next topic. Modeling. Okay. So data modeling is normally people who are in lead, tech lead and above architecture. So they are the responsible for building this data model. Okay. So they'll be uh, capturing all this data models details, gathering all the requirements. And so in BRD, we will be having all the information related to the business. So here, what are the ways that we can build the data models? There are three levels of data models generally for data warehousing projects that we practice, I mean, that we follow. So one is like conceptual data model, like so here conceptual data model mainly focusing on like uh, drafting all the information at the high level. So here we are not defining any table or any column details. Okay. So here we'll be gathering all the import entities of the subject areas of the data information and what is the relationship among the entities. That information we are going to gather and draft it in conceptual data model. So here the data modeler will try to attempt the data with the high level information. Okay. So here will be as to relationships should be documented between the entities. So this is a conceptual data. Okay, so here the enterprise architect. Okay, so lead architect. So they'll be focusing on this conceptual data. And here another we have logical data model. So here we are not going to create any tables here. Okay. So here we'll be defining the attributes for each entity segment and what is the relationships. So here LDM, so we'll maintain like LDM column name. Okay, so there'll be column. For example, every so global ID. Okay, so normally short form will give as GLB ID. So global supplier ID. Global supplier ID. So normally while creating the table, so this is the column name for a particular entity available in like this global supplier ID. But in while creating the table, the column will be considering like this global sub ID. So we need to create a short form and uh, make sure while creating the data in a table. Okay, so here column length max 32 bytes max. Okay. Even table length also 32 byte. Okay. So 32 byte max is that. Okay. So 32 bytes is the max. So if it is exceeds this, sometimes no, it will throw DataStage job will may fail and it won't support actually. So it has some criteria like this is the length should be, this is the table length, this is the column length. Okay, so that is the reason here we'll be focusing on this short forms. Okay. Okay, so these details are maintained in this LD. Okay, we need to prepare the attributes. Okay, so in the detail. So I worked on this LDM and by seeing the documents of CDM, I need to prepare this LDM documents. So for entity wise, so what is the column? Okay, say LDM column, LDM table, LDM column. And this in the LDM document itself here, I need to maintain the PDF, physical data model. That we are going to create the tables here. Okay. And here in the LDM, we'll be maintaining, we will be defining the primary key. This is the primary key. This customer ID is the primary key. So those primary key details and foreign key details, these tables will be maintained in this LDM. And so the same way here in PDM also we'll be defining all these details. And PDM is nothing but apart from documenting the table name, creating the tables, defining the tables and the columns. And here we are maintaining the relationships, like we need to define the primary key and foreign key. So those details we have to prepare with the DDL script. Okay. So DDL scripts has to be reviewed. Okay, so once the review is done, okay, then that has to be checked with the mapping documents as well. Okay, so and everything is synced. Then we'll be sharing this DDL scripts to execute the tables to DBA. Okay, so normally in development environment, developer will have access and they have to follow the prototype, the tables that we are prepared by architect. Okay, so the tables will be executed in the dev environment itself and they will develop the jobs while migrating the QA. So in QA environment, responsibility of taking care of this details is DBA. DBA is the responsible, and sometimes we can execute by using this BTEX scripts. There is some process that generally will follow in the regular environment. Okay. So in QA, in production also, we'll follow the same. Some organization they will take the help of DBA. So there will be dedicated DBA for respective application. So he is responsible for all the stable creation, all the infrastructure related activity. If it is a Teradata, I'm considering the example. And if it is a cloud environment, the infrastructure is maintained by the cloud itself, but the stable creation is our responsibility. We need to take care, we need to prepare the DDLs and execute in the, only admin will have access here to execute this DDL scripts. So normally they won't give permission to everyone. They will give only DRL access. DRL access means select retrieval, select data retrieval access. Select access. Okay. You cannot perform any DML operations. You can only execute only this return the data. So there will be different access that the operation will be. So in PDM, what happens is will be defining all the table details. Tables will be created, and the primary key, foreign key. So those details are now created in the PDM. Okay, so that we need to, by seeing the PDM document, and we need to verify the tables, whether the tables are created or not. So that is the responsibility of PDM data model. Okay. And here for data warehousing approach, here we have for data warehousing approach, here we have a schema. Okay, so what's the schema? Schema is nothing but a model that we are going to build for building the data warehouse. Okay. So here we have two types of schemas in data model. Generally, data warehousing for data warehousing practice, we are using two schemas. Okay, so based on the organization needs and the data and the application, what is the expected result that you want? According to that, we'll be choosing any of this schema, like star schema or the snowflake schema. Okay, so
sir, sorry to interrupt. I have a small doubt regarding that data model. Where that mainly the tables are created in conceptual data model or logical data model?
in PDM. The tables will be, yeah, PDM document where we need to maintain all the table details.
Okay.
Okay, LDM is like will be maintaining all the table details with not in a abbreviated format. LDM. So, but in PDM, you have to do the short forms. Okay. So this is the criteria that we have to follow. We need to check that all the lengths. Okay, so there will be PDM team. They will verify all these things. Okay, even the developer also has to check in case PDM has missed something. Okay, so obviously DataStage job will fail if the length is more than 32 bytes. Okay, so that they need to take it.
Okay, sir. Thank
And here star schema. Okay, so what is star schema? So star schema is nothing but so normally we'll be having the dimension tables, and here star schema that contains one or more fact table. Okay, so here in this section, here we have one fact table. Okay, so what is that one fact table? So here we have. Let me maximize this. Okay, so here product dimension, customer dimension, store dimension. Okay, so time dimension table. So here what happens is there are 4 tables that are surrounded with the fact table. 4 dimension tables surrounded with the fact table. So here there will be a primary key, the dimension table, and that primary key is referring as a foreign key in the fact table. Okay, so that is the way this fact table is built with the surrounding primary keys. So with that, we are going to bring all the data from the dimension table and load it into the fact table. Okay, so this is one method where we will be follow for star schema. And we have another schema that is snowflake. So whenever dimension table is big and it is very difficult to support the dimension table, and what we can do is the entity wise we can split into sub-dimension tables. Okay. So here the dimension table will be product hierarchy, product header, product line. So that will be split into sub-dimension tables, and it will support the main dimension table. Okay, if the different entities, the subject lines are more, then we'll use snowflake scheme. Okay, according to the business need, then we have to choose the scheme. Okay, for example, product line, product. So product has some product head, product header, product line. Okay, so what is the difference between product header and product lines? For example, let's take an example of manufacturing industry, automobile or manufacturing equipments industry. So here there is an agreement between the company to manufacturing industry to the supplier. So you have to deliver with 500, I mean like 1 million volts with the given specification. Okay, so that is the order. Okay, so the order number has been created as a purchase header, and each time delivery, the agreement is we have to deliver 1 million volts. Okay, so now the first delivery they delivered 3 lakhs. So then line number will be created. So like that, the sub-dimension tables will be created to support the main dimension table. So that is the reason here we'll be calling it as a snowflake. Okay. So any doubts, guys, here?
No, sir.
Now let's discuss about, we have discussed in data model like fact table, dimension table. Okay. So what are the different types of fact tables and dimension tables? Now let's see dimension tables. So what is meant by a dimension table? Dimension table is nothing but it has the information related to a specific subject. So that is a dimension table, customer dimension. product dimension, region dimension, okay, customer hierarchy, okay, and also if it is a manufacturing industry, parts attribute, all the information related to the parts. Will part number, part description, okay, part engineering version number, who is a maker of the particular part, okay. So majority of the parts, they will take help from the supplier. Okay, so you can see, for example, those who have cars, so you can see the seats, normal seats, tire, they will be supporting by when the manufacturer will be different. Okay, so you can see all these things. For example, let's take an example of Tata Motors. They won't manufacture all the components of the car. 90% of the products are outsourced. Okay, so only 10%. Okay, so 10% only they will do the manufacturing. Even few automobile industry, they won't take risk. So what and all the demand and supply, according to that, they will do the outsourcing. 95%, even 98% also, they will take help from the supplier. Okay. After, another business where they will get the revenues, selling the parts. Okay. So parts also they will take help from the supplier and they will put their own tag on it and they will sell with the highest price. Okay. So this is also one of the revenue where this automobile industry will get the profit. Okay. So now let's see here. Dimension table types is slowly changing dimension. For example, I have first time I have loaded the data into a dimension table. Okay. So over a period of time, data will change, right? Okay. So for example, the new customers. So I want to know in the last quarter how many cars we have sold. Total number of cars, vehicles sold. Okay. So what is the total? Let's take an example of Tata Motors. So total number of vehicles sold for Nexon. Okay, Tata Altos, Tiago. Okay, and Safari. So what are the different types of vehicles sold in the last quarter? The model wise. Okay, each car has different models. Okay, gear vehicle, without gear. So all this they need a matrix, right? So here the data will be keep on changing. Okay, for example, let's take an example like, for example, a customer has moved from one location to another location. Okay, so here the address details has been changed. So we need to update the data in the system. Okay, for example, here in India we have this other unique identifier, Aadhaar. Okay, so I can change the address n number of times. For example, I moved to new location in the same city, or I moved due to job purpose. I relocated from Bangalore to Hyderabad. So I need to update my address. So once I updated my address in Aadhaar card, and we can update anywhere, like in banking accounts, in gas bill, all the stuff here. So here Aadhaar will maintain all our address details, the change of address. Okay. So that you can see in the history, you can see in the portal. Okay, but the data to display in the dashboard, the data needs to be supported in a database. Okay, so dashboard to visible the picture very clearly with the different segments, but we need to store the data somewhere, right? So that is the data engineer responsibility to store all the data entries, the new entries, old entries. Okay, so what is the current address I want to see? Okay, I want to capture the previous details, previous address segments. The history also maintained here. Okay, so here slowly changing dimensions are classified into 4 types. One is type 0. So type 0 in the sense no change in the dimension tables. Okay, so there are some dimension tables data won't change. For example, geographical area. For example, the geographical area table, it has all the information related to states and countries across the globe. Okay, so here data won't change on frequent basis unless a new nation is formed, then they have to update the data. Okay, so this is type 0 dimension, and here maintaining the current data. Type 1, for example, I want to override the existing data every time. Okay, I don't want to capture the history data. I need to update my system with the current data. Okay, so that is type 1 SCD. Okay, and I need to maintain. So here, what is the drawback in type 1? The drawback here is we are losing the. So here we are losing history data. I want to see the history data. Then we have to implement type. Okay, so in type 2, what happens? We are maintaining current data and as well as history data. So what is the drawback of type 2 here? So the transaction volume will increase. Okay, in the dimension table, here you are maintaining current data as well as the historical data. Okay, so here the data is getting piled up and we need to invest on the memory. But I don't want the full history, I need only partial history. So in that case, you can consider partial history data. For example, let's take an example of a person. Okay, so here Ram. Okay, so he is in Chennai. Okay, so starting from 2000. Okay, so he is in Chennai. Now, okay, so now we move to new location, Hyderabad. Let's take an example. So in SCD type 2, we move to Hyderabad. Okay. Hyderabad. Okay. So in SCD type 1, so here what happens? Hyderabad. And starting of this month, 24/04/01. Okay. So in SCD type 2, what happens? So we will maintain both current and as well as history. Okay. So this is start date and end date also here we have to make 03/31. And here REC indicator or CDC flag. So this is 110, the earlier location, right? And new location. Let's enter the new location, Hyderabad. Okay. So here starting from April onwards. So how long you will stay here? We are not sure. Then we have to enter the future date. Okay. So here record indicator is active. Okay. So name, location. Okay. Start date. This is end date. So just for example, I'm saying sharing this info. So this is record indicator. Okay. But in SCD type 3, what happens? So we don't maintain name, current location, current LOC. Okay. Previous LOG, effective date. Effective from which date is living in the current location. Okay, wow. Current location, Hyderabad. Then, okay, so effective from starting of April. So again, if you move to new location, okay, so then the new entry will be there. And here the location will be keep on getting slapped in a city type thing. So based on the business needs, we need to build the respective dimension table. Okay, this is one type of dimension. And conformal dimension. What is a conformal dimension? So conformal dimension, any dimension table that is used. Any conformal dimension table that is used across the multiple applications. Okay, for example, here I can say like geographical area. Okay, so the country codes, if you want to get country name details, state name details. Okay, so based on the address that we need. So we'll be using this geographical area table. So any dimension table used across the multiple applications. So that is a confirmed dimension. And another one is supplier subtable, EW sub. EW sub. So this is a table, normally it has all the vendor list. Okay. So when I was working in CAT has more than 3.5 lakh supplier list. Okay, so supplier in the sense who is providing any helping the client, helping the customer in any form of any need. Okay, so let's take an example of Infosys Limited. Infosys Limited is a Indian-based IT service company. Their main primary nature of business is building the IT applications, supporting the IT applications. So in EDW subtable here, we'll be having all the information related to that vendor. So what is the base location? Bangalore, India. Okay, so what's the mailing address, billing address? Okay, the bills and all settlement at the New York office. So those entire details are available in this EDW subtable. So if you want to get any supplier information, we need to contact this subtable. So any dimension table used across the multiple dimensions. So that is a conformal dimension. Okay. And another dimensions that we have in dimension tables is junk dimension. So junk dimensions are like is a group of attributes low importance, low cardinal. It contains different and various attributes that are unrelated to other attributes. There is no relationship among the entities. For example, customer, it is hospitality, healthcare. So here, normally for a patient, they will check your weight. So there is no relationship between the patient to patient weight. Your weight is your weight. Other patient weight is that person's weight. So here some flags, weights. So these are comes under the junk dimension categories. Okay. Another one is like degenerated dimensions. For example, when I book a train ticket, the PNR number will be generated. So PNR number is unique only that particular travel. Even if you book a flight, even if you book a bus. Okay, so normally if you book the ticket in ABS service, so here there will be ticket ID. So the ticket ID is unique only to that particular journey. That's it. Okay, so those kind of dimensions will be calculated as degenerated dimensions. So invoice number. Okay, so you have noticed whenever you went for shopping in retail outlets, they'll use the bill and you can see the invoice number there. So those are now considered as a degenerated dimension. Okay. We have another dimension attributes that are role play dimension. So what is a role play? So what is a role play? It's a major the connections. It establishes the connection between the fact table and the dimension table. Okay. So in database schema, star schema here we have seen this, right? Okay, so in the dimension, the star schema where we have seen four tables, four dimension tables surrounded by fact tables. So to build this fact table, the relationship of primary key and foreign. So here the primary keys plays a major role in the dimension table. So those are considered as a role play dimensions. Okay. So any questions here? So this is okay. So this is very important. The different types of dimension table. In an interview, they will ask what is compartment dimension. Okay, so you should be able to answer. Any dimension table that is used across different projects, different applications for supporting the data needs, then we'll be calling it as a compartment dimensions. Okay, so you can by heart all these things. Okay, those who are in job training. Okay. And the next one is any questions, guys? No questions. Okay, everybody know. Okay, right. So now let's move on to fact table. We have discussed till now dimension tables, types of dimension table. Now fact table, fact table. So what are the various fact tables? So here, why we use fact tables is like to sum up the data. The summarized data will be available in the fact table. So what are the different types of fact tables here? Additive facts. Okay. And the next one is what is additive facts? Before going to the next fact table. So here we can do the sum up across all the dimensions. Measurements in the fact table that can be summed up across all the keys here. Okay, so here we have store key, product key, okay, and transaction date and transaction table, revenue on date wise. Okay, so here I need to do the sum up across all the dimensions. So here store wise, product wise, transaction date wise. So here you can see store wise. So store S1, okay. So here 100 is there. Again S1 here 600 is there. 600 plus 100 that is 700. Again here store one S1 is there. That is 700 plus 200 that is 900. Store wise what is the revenue generated? Okay, these are additive facts. And the next one is S2, the store 2. So here we have 150. Okay, and here 300, that is 450. Again here 100, 450 plus 100, 550. So like that here we can check the we can check, I mean like we can do sum up for the individual dimension keys, okay? And product wise you can see P1, P2, and also for transaction wise. Okay, so this is the additive fact. Okay, so here another fact table is like semi-additive fact. So here we can do the sum up across only few dimensions, not all dimensions. Okay, so in this example here, I cannot do the sum up with some other person account. Okay, so I have a bank account. What is the deposit amount? What is the deposit withdrawal? I mean, withdrawal amount. So that is related to only to my account. I cannot do sum up with some other person account. Okay, so here account ID is with respect to date for only to that particular account. Okay, so any measures that we are going to perform only for few dimensional keys. So that will be called as a semi-additive facts. Okay. The next one is non-additive facts. So non-additive facts means that cannot be summed up across any dimension. Okay, so we cannot do the sum up. For example, ratios. Okay, so we cannot do the sum up. Even weight also cannot do the sum up. Okay, and the next one is factless fact table. Okay, so factless a fact table without any measure values. So that is a factless fact table. So here it acts as a bridge between dimension keys to the fact tables. Okay, we cannot do the any measure values. For example, for foreign keys the dimension table and foreign keys in the foreign keys in the fact table. So those are factless fact table. Okay. So this is about various dimension tables of fact tables. Okay. Next, what is a surrogate key? So surrogate key will limit. So any questions, guys, on different types of dimension tables of fact tables? No questions. Okay. So what is a surrogate key? Surrogate key is a substitution of a natural primary. For example, surrogate key is implemented to generate a sequence number in the database. Okay, so in the DataStage job. While loading the data into dimension table, that we will be using as a sequence number that we are going to generate. Sequence number that we are going to generate. For example, I am sharing the outbound file, hard file. I need to share the file sequence number of every file that I am going to see. That I have to maintain in my audit table. So in that case, we can implement this surrogates. So it's generate the sequence number every time. Okay. And the next one is primary key. What is a primary key? Primary key is nothing but not null values. Data is unique here, unique and not null. Nulls are not allowed the primary key. Okay. And surrogate key we have discussed. And unique key. Okay, so one of the common interview question is unique key. What is a unique key? So here unique key is unique and not unique and not null. Unique and nulls are allowed in the data is unique, but nulls are allowed. Nulls are allowed. Okay. And the next one is primary key. This is unique and not null. Okay. Unique and not null. So this is a primary key. Surrogate key is a sequence number. Okay. So with this, we have completed data version concepts. Okay. So on Monday, we will be having session on BigQuery. Okay, how to create a Google Cloud account. Okay, so we'll discuss on Monday. So they'll be having 3 to 4 sessions on BigQuery. How to write a SQL, how to create a Google bucket, how to extract the data from files to table. Okay, so we'll see on Monday session. The Monday session is, there are some students, okay, so the previous batch, like March weekend batch students, February students, the GCP is pending for them. So I will include all, everyone in the batch, okay, so that we can have sessions on BigQuery in the next week. Okay, so meantime, please practice. Please install the software. Those who not finish the enrollment yet, finish the enrollment. Okay. Yeah. So if you have any questions, you can ask me. So here in DataStage, I'll be focusing on scenario-based reviews. Okay. So here, for example, scenario, if it is input is like this, and what is the expected output? I will give you access to the scenarios videos as well. Okay, so that is very helpful for you guys. Okay. So here we have a scenario. Let's see here. So this is the input, 2 files, this is the output. So how you are going to achieve all these things? So that I have prepared a solution in a form of video. So these videos I will be share with you. Okay.
Okay, sir.
Yeah. Any other questions, guys? Okay. So if you don't have any questions, we'll wind up. Let's connect on Monday on BigQuery. I'll be sharing a separate link. Okay. So I'll be sharing a separate link for BigQuery classes. Okay, I'll be sharing this in WhatsApp. Let's connect on Monday for BigQuery schedules. Okay. So those who want to learn DataStage faster, okay. So those who finish the enrollments, I have given already the self-learning videos. You can start going. At present, you can start going through the self-learning videos. You can gain the subject knowledge by going through the videos, and anyway, we will cover after this BigQuery sessions gets completed. Okay.
Okay, sir. Thank you.
Thank you.
Thank you.